All right, so in this video, we're going to be looking at how to rationalize square roots or how to divide with them. Now, if we have a division problem like this that involves square roots, the main trick to simplifying these expressions is going to be a process called rationalization. And the idea basically is that we're going to multiply by something that's going to make either the numerator or the denominator part of our fraction. We're going to get rid of all of the square roots in one portion of the fraction in order to simplify. Now, when we are dealing with typically when we're doing arithmetic, we're looking at rationalizing the denominator. However, when we do calculus, we sometimes need to rationalize the numerator. So later on, we'll do an example where we are simplifying in terms of what's going on in the numerator and not necessarily the denominator. But typically when we're doing arithmetic, when we're doing math, and we have working with all real numbers, then we're working with rationalizing the denominator. Now, the trick that we're going to employ has to do with the difference of squares formula. So if you remember that a minus b times a plus b is going to give me a squared minus b squared. And so that's going to be the trick that we're going to use, because we want to be able to essentially square the square roots so that they disappear, but without introducing any new square roots that we have to deal with. So again, we're not going to be able to do this for both the numerator and the denominator simultaneously. So typically we focus on the denominator when we're working with nice whole numbers and not variables. So what I'm going to do here is I'm going to multiply my fraction by a fraction, but one that is going to be, is going to take advantage of this a minus b, a plus b configuration so that I can cancel out any middle terms. And I'm going to multiply by the complement by taking the minus sign and turning it into a plus sign, or if I had a plus sign, turning it into a minus sign between my two radicals. Now, in the denominator, what this is going to do for us is I'm going to get, again, my a squared minus b squared a is square root of 3, and b is the square root of 5, and I'm going to square both of those, which is going to get me square root of 3 squared is 3, and square root of 5 squared is 5. Now, in my numerator, I'm actually going to have to do the foiling. So, because I don't have any common radicals at all. So I'm just going to, this is the sacrifice we make in order to simplify the denominator. We turn the numerator into a bigger mess. So 4 square root of 3, and then 4 times the square root of 5, and then square root of 2 times the square root of 3 is the square root of 6, and the square root of 2 times the square root of 5, except this is going to be a minus, is also going to be a minus square root of 10. And then in my denominator, then this is just going to become a negative 2. And because of the way my radicals were, it turns out that I can't actually simplify this very much more beyond this. But 3 minus 5 is negative 2. And so what I can do is I can divide each of these by -2. So this will become -2. 4 divided by -2 is -2. 4 divided by -2 is also -2. This will become +1/2 because there's nothing out front to divide by. And this will also become +1/2. So this is about as simple as I can get my expression. Now, this is a very similar process to the one that we're going to use when we talk about complex numbers. And basically, we're employing exactly the same trick because when we deal with complex numbers, the basis for I is the square root of -1. Now, when we do the difference quotient, we will sometimes have to rationalize the numerator. And so recall that our difference quotient is f of x plus h minus f of x all over h. And so in order to simplify, we're going to need to rationalize the numerator. But the trick that we're going to use is going to be exactly the same. We're just going to apply it to the numerator instead of the denominator. So if I substitute my function notation here, I'm going to get the square root of x plus h minus the square root of x all over h. And I'd really like to simplify this. And it turns out the way that I can do that is by multiplying by the complement of the numerator. Again, basically the same two radicals, but flip the sign between them. Now, in the denominator, it's generally good practice not to distribute anything because you want actually for this square root to cancel. You're trying to get the h to cancel. And if you distribute, you're going to have to unfoil anyway. Now here, again, we're going to employ essentially our difference of squares formula. This times this is going to be the square root of x plus h quantity squared minus the square root of x quantity squared and in our denominator, for now, nothing is going to change. But the square and the square root are going to cancel, and so I'm going to get x plus h. And then the square and the square root are going to cancel, and I'm just going to get x. And so now I can cancel my x's, and x minus x is 0. I'm leaving an h behind. And so now what I can do is I can cancel my h's. And I'm just going to get this expression. Now, when we get to calculus, what we'll want to do with this difference quotient is then let h be 0, which is why we needed to get it out of the denominator in the first place. And this, when we let h equal to 0, can then be further simplified. But this is the exact same trick, but now we're applying it to the numerator and not only the denominator, because that's what we need in order to get the simplifying to work.